Hi, in this video, I'm going to review parametric equations. I'm basically going to talk about what they are. I'm going to show you three examples, and I'm going to show you how to use the graphing calculator. First of all, a set of parametric equations basically still graphs x and y just like you normally would, or maybe you use other variables, but you're going to graph two variables on the coordinate plane, but each of those variables are going to be defined using a third parameter or a third variable. So this is pretty cool. You actually have three variables involved, but your visual graph only sees the two variables that are defined by that third parameter. Now, what this does is it expands our use of variables in a pretty interesting way. But actually, if you just pay attention to how variables are defined and recognize that in this particular case, you're still looking at the x and the y axis, your logic and everything you've learned in mathematics still applies. What you could do is look at, let's say you wanted to graph this from t equals 0 to 4. What you would do is you would basically run through a table of values and you would think about, and you could use decimals as well, but I'm just going to run through 0 through 4. It's a continuous graph, but you can use whatever steps you want. And you basically just think about whenever t is 0, what is x, what is y? You run through the arithmetic. When t is 0, x is -2, and y would be 9. And what you can do is you can plot that. So you get -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you get -2, 9. That point right there is on the graph whenever t equals 0. Some people like to just make a little note that this is when t equals 0, but it's not actually physically anywhere on the graph. It's just a point in the xy plane. Then when t equals 1, well, do the math. You get 1 and you get 4. Plot 1, 4. And that point right there on the graph is whenever t equals 1. And you continue this process. You're just plugging in different values of t, giving you corresponding values of x and y because x and y are defined by t or functions of t. So when t is 2, x is going to be 4. And when t is 2, y is going to be 1. So you plot that, 4, 1. And when t is 3, x is 7. When t is 3, y is 0. So you get 7, 0. When t is 4, x is 10. When t is 4, y is 1. So that would give you that point right there. T equals 2, t equals 3, t equals 4. Again, you don't have to put those, but some people like to. You would connect these in what would be a smooth curve because this is a continuous graph. Some people like to draw arrows to indicate the order in which it's graphed over the t values. Now, t is used oftentimes because time is oftentimes considered that third parameter, but you don't have to use time. It could be other parameters. The variables can be defined however you want. Okay, but what one application that I'm not going to go through in this video is really cool is that when you throw a ball up in the air, when you're limited to just two variables, you have to graph height with respect to time. So you have to use your x variable for time, right? But if you actually use parametric equations, you can define x, which is the horizontal position of that object with respect to time. And then you still can define y as a function of time. So you can then actually see the two-dimensional movement of a ball with respect to time, which is pretty cool. So bringing in that third variable gives you some interesting uh, play time. You can do some interesting things with it. All right, I'm going to show you two other common applications of parametric equations, and I'm going to still use t here. Some people prefer to use theta, but I'm just going to stick to t because that's the most common use of parametric equations is bringing in time as your third parameter. And I'm going to just graph this from 0 to 2 pi. Now, this is going to be a good opportunity for you to review your unit circle as well as understand parametric equations. I'm going to define x and y as a function of time. So I'm going to first plug in 0. Think about when you plug in 0, what's the sign of 0? Well, the sign of 0 is 0. So you end up getting 5 times 0. The cosine of 0 is 1. So that ends up giving you 0, 5. Now, it's important here to think about what you're plotting here. You're plotting x and y. So in this particular case, that is what's happening when t equals 0. It's starting there. Now, because I know my unit circle, I like to think of the extremes on the unit circle, which is going to be when the sine and the cosine value is 1. So even though I'm going from 0 to 2 pi, what I'm going to do is I'm going to use my values. I'm going to be a little bit clever here, and I'm going to use pi over 2 as my t value, because sine of pi over 2 is easy to calculate. That's 1. So you get 5 times 1. The cosine of pi over 2 is 0. So that's easy. So you can get 0. So the 0.50, 1, 2, 3, 4, 5, 0 is on there, and that's when t equals pi over 2. And if you continue this, focusing on the most extreme values, it's easy to graph this. If you plug in pi, you end up getting 5 times 0, and then cosine of pi is -1, so you get -5. So you get 0, -5, which gets you down there. And then you'd probably plug in 3 pi over 2. You can probably guess where we're going with here. 3 pi over 2 ends up being -5, 0. That's there. I'm going to go ahead and mark this as t equals pi and t equals 3 pi over 2. And then you can probably guess that when you plug in 2 pi, you return to where you started. And so the graph of this ends up looking roughly like this, which should, you can probably guess, creates a circle, and it goes around like this. So this parametric equation, pretty common one, ends up giving you a circle starting at the top and going clockwise until you get back around to the starting point. You could define t from 0 to 4 pi. You just go around the circle twice, okay? Something else that I'm not going to cover in this video that you can do, pretty common thing in mathematics, is you do what's called removing the parameter. You use a little bit of algebra manipulation and some of your, in this case, some trig identities, and you can actually remove the parameter of t and get a regular rectangular function with just x and y. In this case, it would end up giving you a circle. You could probably guess that it's x squared plus y squared equals 25. And this one would end up giving you a parabola. Obviously, we've only graphed part of the parabola, but you would actually, if you remove the parameter, you'd end up getting the entire parabola. All right, let's just do one more example. Let's do x equals 8 times the cosine of t, and y equals 5 times the sine of t. And let's go ahead and do this again from 0 to 2 pi. Now, this time I'm not going to write down the table of values, but I'm just going to kind of talk you through it out loud. I'm going to start when I plug in 0. If you plug in 0, you get x equals 8 and y equals 0. So 1, 2, 3, 4, 5, 6, 7, 8. So that's when t equals 0. Next, I'm going to plug in pi over 2 because that's going to be the next maximum. In this particular case, if I plugged in pi over 2, I'd get 0 and 5. So that takes me to here. That's when t is pi over 2. If I plug in pi, you end up getting -8, 0. And then when you plug in 3 pi over 2, you get 0, -5. I actually like parametric equations when x is defined as cosine and y is defined as sine, because it feels a little bit right for me. It feels little bit more connected to the unit circle. But be careful, because like in this last example, x was defined with sine and y was defined with cosine. So you just have to be careful about inputs and outputs and plot your points correctly. Okay. This particular graph goes around like this, and you can actually see that it creates what looks like an ellipse. And in fact, if you eliminated the parameters using a little bit of trig identities, what you would probably use for both of these is cosine squared plus sine squared equals 1, and then substitute in x over 5, y over 5, or x over 8, y over 5, and you'd end up getting equations of circles, equations for an ellipse in this particular case. You'll notice this one actually goes counterclockwise from 0 to 2 pi. Something to note, at least, okay? So those are some basic examples of parametric. What I want to show you now is I want to show you how to use the graphing calculator for graphing parametric equations, and just run through a couple things playing around with this on the calculator. So the first thing you want to do is change the mode. If you press the mode button, you'll see if you scroll down, it's in function mode usually. We're going to switch this over to parametric mode. And now when you go into y equals, you'll see x1t, y1t, x2t, y2t. You probably always wondered what that xt theta n button, why didn't it just say x? Well, depending on what mode you're in, that button is still going to be the button you use for various modes. So let's just do one kind of like what we just did before, for sine of t, close parentheses, just to be pretty. And let's do 7 cosine of t, close parentheses. Now here's the important part. If you press window, it's by default goes from 0 to 2 pi just because it's a pretty common application of parametric equations to use trig. But you can adjust this. Obviously, you can go from 0 to 4, 0 to 10. You could go from -5 to 5 if you wanted to. T step just tells your calculator how often you want the calculator to plot a point. And so I usually like to use like 0.05 just to make it really accurate. If you make this step too big, you can sometimes get choppy graphs that are not really accurate representations of what that graph's supposed to look like. You can probably guess what this graph looks like if you've practiced enough, and you probably should get to the point where you can practice this enough to know that this is going to be an ellipse, where the x coordinates are going to go 4, -4, the y coordinates going to go 7, -7, and sure enough, you get that ellipse. If you wanted to, you could go over to the left here, and if you press enter here, you can change the color. But what's also cool is you can change this to this thing that looks kind of like a little tadpole. And now when I graph it, it's a little bit more fun to watch because you can see it. You can actually press enter to pause, press enter again to continue. So you can actually think about inputs and outputs as this is graphing. Because remember, just like anything else, a graph is just a set of points that makes an equation true. If you change this to 3t and this to 3t, you'll notice you actually get the exact same graph, but it went a little bit faster. And you also notice that it's going around 3 times. You can probably think about why that is. Our window is still graphed from 0 to 2 pi. If you're doing cosine of 3t, that changes what would normally be the equivalent of the period on a sine graph. And so you're actually completing the period instead of in 2 pi, you're completing it in 2 pi over 3. So if you graphed this from 0 to 2 pi over 3, you would only go around once. But since we're graphing from 0 to 2 pi, you're going around 3 times. If you made one of these 5t and one of them kept it at 3t, you're going to get all kinds of funny stuff happening because the two sine and cosine are not really in sync. And so you're getting some really funny graphs like this. You're not going to really experience this much in your life. I just wanted to show you, and you can play around with it some more on your own and have a little bit of fun with it. Anyway, that's it. That's parametric equations. I hope it helps you. And we're going to actually get into the calculus of parametric equations in the first class back. All right, bye.